All right, now we're going to look at the most common type of interest, which is continuously compounded interest. So in this case, the idea is that the bank is just constantly running an algorithm to figure out how much money is in your account. So we start with our compound interest formula. And now if we want to think about continuously compounding, that means that our n is going towards infinity. But n going towards infinity with this r on top of it, I don't quite know what that's going to be as my limit happens. So really what I want to do is I want to substitute this to have just one variable. If we let x equal r over n, then as x is going towards infinity, this becomes bigger and bigger. So I don't want that. I want to have 1 over x in here. So instead, if we let this happen, then we have trouble. So instead, we let x equal n over r. It can be rewritten this way, that my n value would be r times x. But if I look at it over here, this is where it comes from, because now if x is n over r, then 1 over x is r over n. And my formula becomes p times 1 plus 1 over x. If I substitute in for the n, then I'm going to have rx to the t. If I rearrange this to be in this form, well, I just want r to the t, excuse me, on the outside, which means on the inside, I'll have p times 1 plus 1 over x to the x, and all of that to the rt. The reason I'm going to do this is because I want to have just one variable that I'm manipulating as I'm letting my number of compounds go to infinity. So the reason I have to rearrange it is because in here, I'm never going to be able to isolate just one variable. So by rewriting this as one variable, I can rearrange my formula to have my x isolated. So now, if we let x go to infinity, well, let's look at what happens in our calculator. So if we go into a graphing window, let's see if I have one open. I do. All right, so clearly there's something exciting in there. Let's clear this out. All right, now if I make this, well, I still want to have equals. 1 plus 1 over x raised to the x power. Now if I graph this, I'm not seeing anything, so let's go menu, and let's do a zoom standard, just to go back to sort of a normal window. Okay, so now here's a function. I'm wanting x to go to infinity, so I want to zoom out in, let's move my label, and now let's drag my axes a bit. So I see that it's leveling off. So let's go and look at our table. So let's Control T and see what's happening. I want to know what's happening when x is getting really big. So I'm going to take my menu, go into my table, and I'm going to edit the table settings to make my independent variable one that I ask about. So instead of automatically filling in the x's, I'm going to say, ask me what I want for x. So let's see what happens when x is 100. And if x is 500 and 1,000 and 5,000. All right, hopefully this number is looking familiar to you. And this number appears to be going towards E. So now, if we let x go towards infinity, the limit as x goes to infinity of 1 plus 1 over x to the x is the value E. So all of this I can replace with E for continuously compounding interest, and we say that the formula is PERT. So P times E to the RT is the formula for continuously compounding interest. All right, so now I'm going to leave you to do example 8 to calculate simple interest at 14%, 11.5 but compounded monthly, 11.25 compounded continuously. So I want you to read through this, figure out which one is best, and we will talk about it in class.